Thank you very much. Thank you. Yeah. All right. So welcome everybody. I know there were quite a few people in Lesotho coming in. I think this might be them. Somewhere along the line, they didn't realize that South Africa was voting. So unfortunately, they attended the meeting yesterday, but we were still at the voting station. So, but welcome everybody. This is the second part of a two-part in which we discuss resources that you can use for robotics education. And at the start, when we on Tuesday when we started out, we kind of said there are many resources. So there's really a plethora of resources that you can use, but obviously not all resources are relevant to your teaching or to your class or to your community. And there might also be resources that you need that are not currently available. And so this is part of an ongoing research project that we have going. And on the one hand, we need to identify the awareness of the available resources. And on the other hand, we're saying we want to know what resources you're using and whether you effectively use what you have that is available. And so Dr. Dusevic will join us hopefully later. She's just busy teaching, but she'll also join us later. And Anzani will also put on, at the end of the session, on the chat, she'll put a link. And we'd love to know from you. It takes about 3 minutes. We'd love to know which resources you do use and then which resources you maybe need to use or would like to use or would like to have available. And so that is going to be an ongoing conversation. We also have on the research link, we also have an option whether you'd like to contribute to future research, whether you would like to be part of an interview or a discussion. And we will be presenting the results. We hopefully will have a write-up about this about the end of August, and then we will be presenting what our findings are in September in the form of a knowledge cafe, where we can have a further discussion and say, what are the resources that this community of practice are using, and what are the gaps that this community of practice need to advance robotics education at all levels of school. So whether we're at grade R or whether you're high school, what are the gaps in the available resources that for robotics education? Okay, so without further ado, and I'm going to share my screen, and I'm going to ask the team whether you can see the screen. All right, let's go here. All right. And can you see my screen? Let's do unit 3 first.
Not yet.
Not yet.
Now we can see your screen. Thank you.
Oh, excellent. And you can see the slide version of it.
Correct, yes.
Okay, all right. So this is, as I said in the beginning, there are 4 parts to this discussion, and with the ongoing research that we want to do as well. And in unit 1 and 2, so on Tuesday afternoon, we did a general introduction to say robotics is really about the fundamentals of engineering, the principles of programming, and then what happens in between is then your 21st century skills that you develop. And so we did an overview in the unit 1, and unit 2, we really concentrated on building. So building different structures, building models, getting models attached to robots, and then getting the robots programmed to move. All right. So today we're going to do programming in unit 3, and then unit 4 is kind of the wrap up and pulling it all together. And I'd love to have input from you. So the presentations aren't very long, but we'd like to have conversation as well about it. So that's where we are. We're doing programming of the robots and the options that you have available. And then unit 4 is like everything else that's available, and to hear what you are using and what is effective for you. All right. So just to come back, now we're just going to do the programming of robots. And I just on the outset want to say programming is on a continuum, and really programming needs to be demystified, because programming is always thought of as so complex and so difficult, and it's not. It's just where you start. And so for many years I've been teaching text-based programming, which is a really difficult place to jump into programming. Programming, however, has got a whole continuum to the left of it, and so that we start the grade ones, we actually start with the grade R's with unplugged programming. We start with them with unplugged programming, and then we kind of move up to icon based, all right. And then by the time they start reading, we start using drag and drop Scratch programming. And Scratch programming you can read at least, so it's called word programming, but it's not text based, where you have syntax and semantics, and when you don't have a semicolon, then the whole thing doesn't work, or something stupid like that. So we really want to guide the learners from grade R and have a journey. There must always be a pathway, and so you just keep moving, and you'll see in the programming that's the options. Okay. So programming fundamentally is about problem solving. It's conceptualizing a problem, and that's where your computational thinking comes in, to say, how do I take a problem and translate it into a program that then can be executed. All right, so programming is about programming principles, and there are only 3 flows in programming. You can either do linear programming, so you get this and this and this, or you do something repeatedly for a number of times, and that is called repetition or loops. And then the other one is decisions, where you either do this or that, and that's usually determined on the value of a variable. Okay, but programming is a language, and it's the language that you need to learn. That said, if you know your programming principles, you could really pick up another language very easily. All right, so whether you are speaking Delphi, or whether you're speaking Scratch, or whether you're speaking Python, or if you are a long-time programmer with a COBOL or Fortran, whatever the programming language, the principles remain exactly the same, but it is abstract. So one of the things why robotics is then used to introduce programming is because it's concrete. All right, so it takes away the abstractness of programming. So if you have a move block, your robot will move, and if you have a wait block, your robot will wait. All right, so that's the and if you program it to go 2 rotations, it's going to move 2 rotations. So that is the concrete execution of whatever you've written your program. But you're commanding a machine, so you really are taking the programming is the commands, and you're taking it to a machine, and then the machine will do something. Now, part of that thing is, if your commands are correct, the robot will move correctly. If your commands are not correct, they're incorrect, your robot is not going to move correctly. And then, as much as you want to blame the stupid robot, it's not the robot's fault, it's the programmer's fault. The machine, the robot, has no intelligence of its own. Nothing. Absolutely nothing. Whatever you are writing in your computer programs is what the robot then does. Okay, so please don't ever blame a robot for being stupid. Okay, so when you focus on the learning to program, there are alternative pathways, and I would say it would be very unfair to introduce grade R's to the world of Python programming with all the syntax and semantics. Rather, introduce it in a fun way and address the learners where they are. So the grade R, they can do unplugged coding, and they can learn computational thinking. They can develop computational thinking skills. Okay. And then let the learners learn. Please, you as coaches, please do not ever do programming for your learners. You're doing them a huge injustice. All right. And there are options to introduce programming with a robot or without a robot. There's concrete ways and there's virtual ways as well. And I'm going to show you all that as well. All right. So when you introduce programming, you really want to start with something concrete. And then you gradually move to abstract. So the learner should be able to conceptually think in Python as a development, okay? And then we go visual, we drag and drop little windows or little blocks, and then we move them to text, all right? But you've got to keep on moving, all right? And so they will not realize that programming is oh so difficult, because it's not, because you've developed these skills. And so you as the coaches are going to introduce them to programming. So at each programming lesson, you introduce a principle, whether it's looping or switching or decisions or input or output. All the fundamentals and principles are there. You just kind of, as you go along and as you're coaching or teaching your learners, you will introduce them to another concept. All right. So here's the programming languages. And if anybody knows programming languages, you just need to zoom in on Google and say, what is the programming continuum? Well, there's many options. All right. We want to hone in on what's easier for you as coaches to teach your learners. All right. So this is our introduction to programming. Grade R's, we definitely can develop unplugged coding options and computational thinking skills. You think the children are just playing. If you're you use the opportunity to teach them unplugged coding or computational thinking skills. Okay, then grade 1, 2, and 3. All grade 1, 2s, and 3s in the schools are using Scratch. Scratch Junior is just a subset of Scratch. Okay, so I would really introduce the learners to Scratch Junior, get them to tell stories, get them to start writing code, but it's storytelling. Scratch was developed for storytelling. And so you actually have a multi-purpose. You can have learners developing a vocabulary as well as learning to program. So it's like no thinking there. In terms of robotics kits, we use the WeDo kits, and then the WeDo has the icons that drag and drop. The Scratch, the Spike Essential has got Scratch, but there are two options. There's the Word, and then there's the Scratch. Okay, so you can choose which one. And I think, to be fair, the learners say in grade 1 where the programming, the reading skills haven't been developed, let them just do the drag and drop icons, and then move them to Scratch as soon as they can start reading. So there's a win-win situation. But from grade 4, and I've put Python in brackets there, I would rather first start them on the EV3, on the Scratch icons, and then move them to Python. And so if you're using an EV3 robotics kit, you will use the lab version of it, EV3 lab. If you have got EV3 robotics kit, you can also use EV3 classroom, which is Scratch based. And if you're using the Spike Prime robotics kit, then you can use Scratch. Okay, so definitely unplugged, then Scratch, and then we move on to Python. Okay. All right, so the alternative to physical robotics kits is using free downloads. And I just would like to put here, you don't need to buy anything. And if you're struggling, please let us know. Okay, so I introduced Bricklink Studio to you on Tuesday, where you can design robots on Bricklink Studio. The software, the Spike Prime software is free. The EV3 Classroom software is free. And what we're going to talk about now are simulations for learning and programming. There's a really cool little app called GearsBot. And GearsBot is a little robot. It doesn't look quite as organized and colorful, but you can have a little robot on a screen. And so that allows everybody to test their programming skills. And GearsBot you can program in Scratch, and then it gives you the Python equivalent. So it gives the learners a kind of a preview of what Python programming should look like. All right. The other one is the Virtual Robotics Toolkit. That is also downloadable. There's a 60-day trial period. And if you have a computer lab and you're able and you have a budget, I would definitely contact the developers and see whether you can get a classroom license. And if anybody's interested, I do have yeah, I'll leave it at that. Okay, so this is now, okay, let's just go back. This is now all the little pictures. So this is what Scratch looks like. You download it, and then you can get a little picture here, and you put a little person in. It's called a sprite, and you can add other little thingies, and you can make them move. And so the Scratch Junior is also drag and drop little icons that you can put in place, and you'll see it's all color coded as well. So highly recommendable. Let's start with Scratch Junior just to get the kids over their fear of computers and programming something. Okay, and then you have the storytelling where they can, it's a little bit less abstract. They can write their own little story, and then obviously they can tell their story, which is what you want learners to be able to do, to explain to you what they've done. All right. And so this is what it looks like, and then you drag and drop these icons here, and this is your little program, and this is your sprite, and you can you can change the background, and you can write little sentences and things like that. Okay, so then that is Scratch Junior. Scratch, again, looks very similar, but now we're starting with what you know as Scratch coding, and so it's all color-coded in these colors. And again, There are projects that you can use. Which you can download and use. You can use all the resources. Scratch Junior and Scratch, there are all these resources that you can use. All right. Now we come to WeDo Robotics. You can either use the WeDo. There's a software introduction on YouTube, and you can coding with Lego. The WeDo 2.0 from Lego Education. Here, this is what the coding looks like. Okay, you can see it's very much picture-based. If the learners know what the icons mean. What we have found is that you can put all these lessons up on the board so they understand which lessons are which, and then you're also teaching them to read. The WeDo Robotics does have a whole lot of lessons. They've got lessons and they've got activities. That's in terms of resources, it's all there. You can see over here, these are the little robots that you can use, build with the WeDo, and there's some projects. So they are really projects already written that you can download and that you can use. So in terms of resources, I would recommend that you first use what's available and then you modify it to the needs of your learners. All right. But in terms of grades, I would definitely think the grade 1s can start with this. And then you can move them onto Spike Essential. Again, this is what the programming looks like, either in little icons or in the Scratch version of it. There are projects. If you download it, there are projects that you can do, and each project has got lesson plans, worksheets, activities, step-by-step building guides. And you just need to include it also on topics that you have in your classes. All right. So if anybody needs more information, happy to share. But there are gazillion resources for programming in grade 1, 2, and 3. Okay. Then from grade 4 to grade 10, it now depends which kit you've got in your classroom, which programming language. All right. So the EV3 robotics kit can be programmed in EV3 Lab. I'll show you that, or the EV3 Classroom, which is more Scratch based. Okay, if you've got a Spike Prime robotics kit, you can program in Scratch. Program in Python. The EV3 can be programmed in Python. It's a little bit more complex, but it can also be done. Okay, so this is what EV3 Lab looks like. You can see it's icon based. There's nothing wrong with it except that it's a drag, it's and it's icon based, and it's quite intuitive, and it's a good start for the learners to start learning. All right, then you move them on to EV3 Classroom, and I would suggest if you have, especially if the classes are already doing Scratch in grade 1, 2, and 3, then they already have a background to Scratch, and so then moving on to EV3 Robots with EV3 Classroom, it makes it easier transition. Okay, then if you use the Spike Prime robotics kit, then you'll use the Spike Prime Scratch programming. Okay, and also same colors, same layout, and it's a much easier transition if they've done Scratch in grade 1, 2, and 3 already. So this will just be a natural next step. Okay, the Spike Prime Python, there are a whole lot of lesson plans for it. There are tutorials. There are tutorials that you can use. There are tutorials that you can present in your class as well. Okay, and so it's all there. I would just highly recommend that you plan beforehand, so you make sure that whatever resources or media that you're going to use actually addresses the lesson that you're presenting in your class. All right. Python, at its very essence, is a text-based language. Okay, and what I found in the years that I've been teaching Python to first and second year students is that because it's such a diverse group of students, it makes it easier to present Python as within the Anaconda environment, which kind of reduces the complexity of installing software and the technical things that need to be adhered to. So this Python in an Anaconda environment is easier to teach. Learners do worksheets. They can test code, and the error messages are easier to follow. Okay, we are busy putting together a Python MOOC, and so these are some of the examples. just small examples for the learners to understand the programming principles. All right, so there we go. And now for the virtual. So if you're going to go virtual, GearsBot, that's the link for them. You can see the programming is also very much Scratch based. Okay, it's got the same look and feel as Scratch. And this is the environment. There are the blocks, there's the Python, and then there's a little program. Yeah, there's the robot. So there's a single sensor robot. It doesn't look too great, but you can make it move. And then there's your field that you can make it move. And obviously, if it goes too far, it's going to go off the virtual table as well. And so you can test your code to see whether your code actually works. All right. And then, of course, there's this plethora of resources. All right. Here is there's a line follow challenge. There is introduction. There are online tutorials. It's all there. It just depends on what you need to use for your classes. All right. And maybe we need to do a practical and kind of discuss how to teach robotics using GearsBot. It's a very viable option. Okay. And it's free and available. There's lots of tutorials. Each team of students can design a robot. I don't think we should go learn a single. I do think robotics needs always to be a collaborative team event. It says it has a collection of worlds, so where the robot is, and there's a challenge, and you can do Scratch program, Python programming. The Scratch programming will be easier. The Python program will then allow you, so the students can see. And I put there more discussion sessions, question marks. So maybe if there are maybe we can do that on our interviews to kind of get a work group together for GearsBot. Okay. The Virtual Robotics Toolkit, you can get a trial version. And when I last found out about it, it was about 700 Rand a license. So that's per laptop for a year. But of course, it depends on the exchange rate. Let's wait until the election come out and then I'll update this one. So if you're thinking of doing that, maybe get a class license. I don't know, that's maybe an option if you have a large computer lab. All right, so this is what the Virtual Robotics Toolkit looks like. It's got lots of competitions in it. It's got maths, and it's got this was programming in Lego Mindstorms. This is the classroom, EV3 classroom, but I mean, you can program in Scratch as well. Okay. And so what is actually also noticed is that you can program, if you build your robot in Bricklink, I think it's Bricklink Studio, now I speak under correction, you can actually pull your design into Virtual Robotics Toolkit, and then you can program it as well. The cool thing about this is you can test code. So you would be able to test your code. Multiple learners could all write the code for a robot and then download it, put that onto a robot. All right. Also, a gazillion and a half Virtual Robotics Toolkit resources, lots of tutorials, lots of videos, lots of explaining. It's all there. And so maybe this is also something for further discussion, is understanding the resources that are available. Yeah, more and more and more. All right, so this is the licensing. There's a 45 file, and there's a key there if you want to have a free download. I'm happy to share that information. There are demos. There's always demos. And so that's the end of Unit 3. And I will just, before I stop this presentation, I'll just say that I will upload these PDFs, and I'll put them on MOOC 1, M1. I'll put them all there as an additional resource. Okay. All right. I'm going to stop sharing, and I just want to ask Tamela, are there any questions? Do we have any communication? Tamela? Hello, is anybody here?
Yes, we are here. Sorry, I was talking and my microphone was muted. Okay. Ladies and gentlemen, we even have Johannes in the house. Ladies and gentlemen, if you do have any questions, please feel free to raise your hand and I will attend to you, and I'll also enable your microphone. Feel free to raise your hand.
Is there no hands? Oh dear.
Oh, there's
there we go.
Sarai.
There we go.
Your microphone has been enabled, Sarai. You may unmute. Yes, you can unmute. I've enabled your microphone. All right, I see Sarai is struggling.
Oh dear.
You can unmute. I've enabled your microphone. Lulama, your microphone has been enabled as well. Feel free to unmute.
Okay, good day, everyone. Dr. Hoss, I just want to know what's the difference between coding and programming, just for my own knowledge, just the difference, yeah.
Okay, so really we want the coding is what you write, the actual code. All right, so that's actually what you write is the code. Programming is the whole concept of being able to look at something and put a solution together and then to translate your thinking into code. It's a process. All right. And programming also includes testing your code to make sure somebody can't hear. Tumelo, is there somebody on the chat that says they can't hear?
My mic is not working. I have used the quick capture. I can't even hear the audio. It's Mr. Mike Mulife.
Hello, Michael.
I think he must log in and log out. Perhaps it might be the problem. Apologies for that, Mike Zozo.
All right. So really the coding is what you write. The programming is kind of the whole essence of being able to design a solution, to write it, you can even write pseudocode and then to get it into code that you can execute and then to execute it and then to test it and then to improve it. That's the whole programming realm. Okay. And that is where the 21st century skills come in and which need to be developed in our learners, is to be able to look at a problem and understand what the solution is and then to be able to translate it into code and to test the code. All right. I see Sarah has still not unmuted herself.
I see Sarah says, is there any possibility we learn the Spark Prime as well as EV3 is disconnected and we can't buy? Yes, you can definitely learn the Spark Prime. Definitely, 100%.
Yep. We've got some Spike Primes here as well. No problem. All right. So I'm going to, thanks to Melo for that. Can I continue? Are there any other questions on the chat?
No questions on the chat and no hands are raised. You may proceed.
Thank you very much. I've got a presentation now, kind of to wrap it all up. And then hopefully we'll have some discussion about what everybody is using in their classrooms. All right, so it's back to sharing time again. There we go. All right, so now we're going to Unit 4. And my slideshow. All right, Tamila, can you see?
Yes, I can see. You may proceed.
Unit 4, here we go. All right, so this is kind of putting it all together. And maybe we can have, when we present our research to see what is happening in this community, it'll be interesting to see what is actually being used. And maybe we need, and you can think about it, maybe we need more interactive practical sessions. Maybe we need, I don't know. All right. So really, the resources that are available, there needs to be, you can't just decide you're going to use them, you need to have some planning about it. And part of the planning is setting you and meeting the goals towards sustainability in robotics. Okay, so many of you might just be starting, some of you might have already done this for 2 or 3 years. But what are your goals for this year? Do you want to have all learners at least being able to do a Scratch program? Do you want all the learners to have at least built 2 robots? And then what is your 3-year vision for you and your team of learners? And I really think one of the things about robotics education, it requires a team effort. And so if you can have a group of educators at your school that can all move together in the same direction, we're here, we're listening to you. Obviously, in that is what is your commitment and who is on your team. They say many times on a team, it's not having the right people, it's not having the wrong people. So if you can have a team of people that are like-minded and all focused and all move in the same direction, I think you've got a winning team there. And then to be kind of have a reality check and say, what are the challenges? And I'd love to hear about that as well. And then what plans can you make or put in place to address these goals? So if you need some resources, what do you need? Is that really what you need? Or is there are there alternatives to make robotics education happen in your community? All right, so it's about learners, which grades are they now and where they're going. And there's always, with all these resources, you need resources for your learners. That's granted. But you as the coach, what resources do you need? Do you need training? Do you need teaching material? Do you need lesson plans? So that is all part of your vision. All right. And then your support, educators, community leaders, parents, friends, and then what you need. What do you need as your resources to reach your long-term goals? Okay. Okay, so this is kind of wrapping it up. There's a really good article, Accessible Educational Resources for Teaching and Learning of Robotics. And in this article, they say that for robotics resources, they're kind of three categories. The one is sequential. So that will be like courses, MOOCs, or massive open online courses, short learning programs, something where you move towards a goal. All right. Then there's the random stuff, and I'm not sure how many of you enjoy watching TEDx videos. That is also a possibility. All right. And then there are YouTube videos. There's lots of YouTube videos always. And then there are tutorials as well. Okay. Now, linked to that, then there are resources to support practical teaching. All right. And so linked under or grouped under that would be practical workshops, robotics competitions, which are practical, where learners have to participate. All right. All right. So let me just go on here. All right. So the first one is the sequential stuff. Okay. So the sequential is usually one thing, and then another thing, and then you just a minute. So there's always there's one. So if you start with M1, then you'll have Unit 1, Unit 2, Unit 3, Unit 4, and then you go M2. And so there's a sequence in your learning, all right? And then robotics education is also get 1, 2, 3, and 4, and then there's cyber. So everything has got a sequence. For those maybe who are not aware, there's the DBE 001 and 002 for all educators for grade R to grade 3. So there is from R to grade 3, term 1 to term 4, week 1 to week 9. They're all the resources, and all you can do is download them. But obviously, at some stage, there needs to be, instead of take, you need to give. And so as a community, we're saying, all right, if you've used the stuff, how can you improve it? Or what do you have to contribute to the community? All right. Then there's the random access resources. And yeah, this is TEDx. And so there's these really cool things about robotics and robots, and sometimes these kind of once-off things, show it to your kids and let them see what robotics can do and what is waiting for them, because you're preparing them and inspiring them for their future. And so maybe a once-off random access TEDx talk might be good. All right. And education in the future, well, there's a whole lot of stuff there. Also, just once off, it doesn't have to be a whole series. It's just a once off thing, but it'll definitely give you food for thought. All right. Now the resources for practical, so for doing and really to support you in your teaching and learning. And I've spoken now about the programming, but robotic simulations, they're available, they're there. But the other one is for practical is how do you use maybe robotics to teach physics, or robotics to teach maths, or robotics to teach, I don't know, whatever language you want to teach, and robotics. Okay, and in the environmental science and robotics MOOC, we are using the environmental science platform to introduce robotics. So we've got a situation. All right, and then you've got the robotics competition. So you're encouraging and creating opportunities for all learners to participate in at least one robotics competition. And just onto that, the STEMI board of SASTA have got a whole segment for robotics competitions, and there's a whole collection of competitions. Each has a different, obviously a different requirements, but really from grade R to grade 12, learners can participate in robotics competitions, which will then also support your teaching and learning of robotics. Okay, so in all competitions, there's always an engineering part, a programming part, and a 21st century skills part. So some competitions have a greater emphasis on engineering, some on greater emphasis on programming, and some have a larger emphasis on 21st century skills. Okay, and then in a competition, there's always a team. And each team member must have a role. So whether you're a builder or a programmer, and it's always good to have multiple builders, multiple programmers, and then have them share responsibility. So whereas you could have a group of builders, they still need to know what the programmers do, and the programmers still need to know what the builders are doing and things like that. Okay. I just want to also just say there's various approaches to problem solving, and not everybody sees the problem the same way. Okay. You will get on a team, you will get some learners that can think, problem solve the big problem, and others will focus on the smaller details. It's not to say that one is right and one is wrong. It's about problem solving skills, how you approach a problem. Okay, but here's for you as the coach. You're going to coach and you're going to mentor, but you may not do. All right, the coaches must coach and the mentors must mentor and the learners must do. All right. You are removing or taking away their opportunity for learning if you do that. Okay. All STEM Olympiad robotics and Olympiads and competitions for robotics are annually themed, and everyone has a different requirement and what you have to bring and what is required. And so there's a whole lot of different competitions that needs to be part of your planning as well. All right, so I'm going to introduce you now to some competitions and think about it and see whether it'll fit if you start planning for 2025, how it'll fit into your plan, and then what are your goals as well. All right, so there's 3 competitions that are really just local, and then 3 competitions that have got a regional, national, and an international. Okay, so the virtual robotics toolkit, virtual gear is on the MOOC portal. The Robothon is a one-day only competition, and the Conquesta is a quiz. Okay, and then World Robot Olympiad again has got a regional, national, and international. First Lego League has got 3 programs. Discovers for your grade R's, Explore is for grade 1, 2, and 3, and then Challenge is from grade 4 to grade 10. And then First Tech Challenge, we build the big robots, the remote controlled, laser cut, 3D printed robots. And we usually say from a grade 10, 11, and 12. But we can take them younger. It's usually from 13 to 18. And usually by grade 10, they're old enough to tackle that. All right. Virtual gear, it's online, and we're happy to present a section on that. If you go to the M3 MOOC portal, you can download under syllabus, you can download all the information, and we're happy to share that information. If you'd like some more information, on the Friday afternoon session at 3 o'clock, we can happy to share and show you around that site. Okay. Oh, that I just see I haven't got the 2023. I was going to say it launched on 2024. It launched in February. No age limit. I just don't know whether this video is going to work. It's not going to work. All right. So it's very hands-on. You can see these children are working in a team. They have used, just hang on a minute. Here are containers that they buy from the shops. And it's all a whole story together, which they need to, imagination story, but all have a theme. All right. This was the Gone Tubing one. All the challenges are available on the MOOC portal and also videos. Okay. The Robothon video, the Robothon competition is a competition where learners arrive with just their robotics kit, and they get 5 hours. And so they get introduced to the challenge. They sit in teams of 4 learners, and they get 5 hours to score as many points as possible. All right. The Conquesta is, again, a challenge. I'm just going to show you what it looks like. So there's usually an engineering part, so kind of questions. There's the programming part, and the programming does include the Scratch programming version as well. Then there's a challenge. So this challenge was about robots in agriculture, and so there was a whole story about robots in agriculture. And then there was a comprehension where you get a passage they have to read, and then they have to answer questions related to the theme. And this was robots in agriculture. Okay. So those are the first 3. The virtual gear is online. The Robothon is a 1-day only, and the Conquesta is a quiz. All right. The other 3, you've got a robot that you need to build and to program. All right. So this is WRO. You'll see there's a regular category where there's a mat and the robot has to do certain things. There's an open category where you have a group of learners who present a project. What's really cool about that is we get students to come and volunteer to be the referees in this competition. Okay, this was just from the website for the WRO South Africa. I'm going to go onto the site after this presentation, but you'll see there are categories and there's themes. Here, there's the Robo Missions, which is a mat with missions. There's the Future Innovators, where they've got to design something. The Robo Sports is lots of fun. We played Robo Soccer. And then the Future Engineers are for the seniors, for the students. Okay. Just on this, the WRO teams are usually 3 members on a team. Okay. So now we go to First Lego League, and there's up to 10 members on a team. They are aged between 10 years and 16 years, although if they're 16 at the beginning of the year of the competition, they can still enter. And also, they have a theme. You've got to build and program a robot, and you've got to present a project, and you've got to display teamwork that you as a team have put this robot together. All right. The First Lego League theme that's coming out in August is called Submerged. So it's got to do something about underwater, I think. Looks underwater-ish. But let's see where that goes. Previous themes we've had is Superpowered or Cargo Connect. And then there's also a competition for each age category. So for Discover, they've got to build a model and solve a problem. And more importantly, they have to be able to explain how they solved the problem. Okay? Then Explore, we start programming. Okay? So you have to build a model that moves. And then you have to build your solution around it, which is usually a model, which the learners need to explain to their reviewers. And you'll see here the team has got a whole model around it. You can see here the team has got a whole model around it. So something has to move, something has to be programmed, and then there's a story that they will explain how that works. And then, of course, a show me poster, which they need to develop. It's not the parents' work either. It's the learners trying to explain what they've achieved. Okay. I think underwater submerged is going to be quite a difficult theme, but it opens up a whole avenue for us to explore the seas together with our learners and to get as much extra multimedia into the classroom as possible. It's just an amazing learning experience. All right. The challenge, it's also submerged, obviously. It's a submerged, but we've been through several topics. But there's a project. So there's a project on a real world issue. There's the robot design, where you have to choose from about 16 missions, which missions you're going to do, because you need to get optimal points in 150 seconds, which is 2.5 minutes. Okay, and then you've got to work together. Now, if you are new to this, the competition launches the first week in August, and there will be coaches training for the whole month of August. You're welcome to join that. And then volunteers, like judges and referees, will be then trained in September. And so there's training. Again, there are resources, and each of these themes comes with a gazillion resources to guide the teachers. All right. Usually 10 learners. I found that 8 is usually a good turning point. Each team has a kit and a laptop. There are 12 sessions. You've got a team meeting guide, so you have a document that you can use. You've got the robot, the project, and the teamwork. Okay. And obviously there's ongoing development. So if you say, what do you want to achieve this year? Maybe you want to introduce 2 teams to a competition. How does that go forward to next year and to the following year? And you must have a strategy. Remember, your learners are going to move up. So if you've started with Explore, what are they going to do when you grow up to grade 4? Okay. FTC, big, large robots, laser cutting, project management. But it's definitely something to put on your bucket list to get the skills required. And here's also an opportunity for community involvement, where maybe you have engineers in your community who would love to then assist your students in mentoring. You can be the coach, but mentors, engineering students, engineers out there. And if you can get engineering companies in your community to sponsor your teams, I think you also have a win-win situation, because then you're creating capacity and preparing the learners for their careers ahead. Okay, this is what it looks like. There's usually 2 teams on either side, and then the red team and the blue team, and there's always remote controls going. And then, yeah, it's a lot of fun. It's very loud. Okay, that's kind of the bigger robots that we build. And I'm going to stop here with why I bother. Unfortunately, there's a perception that programming is very complex, and there's always the perception that science is difficult. So we are seeing a dwindling number of students actually matriculating with great science qualifications. And our grade 1s of 2024 are our science matrics of 2035, and they're going to be going into university. And so we need to prepare them for their future. By that time, I'll be long retired. But we need to prepare them. We're doing them an injustice to think they're going to thrive in their future when you haven't prepared them. So why I bother is that only 1% of the robotics teams currently come from Africa. When Cabello and I started the ISET project a gazillion years ago, we had a million inspiration vision to get 1 million learners just to build one robot. And I think we are working very hard to get to that vision, and it's just a moving target. It just is a moving target. Really exciting is we have the Africa Open Championships coming in 2025, so it's less than a year away, and we would like more than 50% of the teams to be from the African continent. Currently, we only have robotics teams up here: Tunisia, Morocco, Algeria, and Egypt. We have Nigeria and a couple of countries here in the middle here. And then we have South Africa. I'm happy to say Lesotho's on board, and Lesotho's down here, and Swaziland's on board. And we've got Zimbabwe, we've got Botswana, and the community grows, and it will only grow with inspired people like you who are going to walk this journey with us and be part of a real community to make a real difference in this country. All right. And in the country and on the continent, and I am really inspired. And so thank you very much. All the resources are there. We just need to make sure that they are usable and useful for this vision. Okay, and I'm going to stop there for a minute, and I just want to share. This is the website from the WRO competitions, if anybody's interested. If anybody wants to go and look, it's called Earth Allies. I don't know, there's the pink flamingo. I don't know what that means. Earth Allies is the theme for WRO. So I'm happy to go through this theme as well So on the one hand, we've got Earth Allies. On the other hand, we've got First Lego League, which is looking at submerged. I'm kind of seeing some overlap there, but we can open that for discussion. All right, I'm going to stop sharing and I'm going to stop talking. And Tumela, over to you. Are there any questions, any hands raised, anybody?
Ladies and gentlemen, this is the opportunity for you to raise your hand. Feel free to raise your hand and then I'll enable your microphone, or you can use the chat box if you need some clarity regarding Dr. Ho's presentation.
I'm just making sure, Tumelo, did Anzani share the link on the chat?
No, there's no link on the chat.
Okay, then I'll just go and find it quickly. Just give me half a minute, but I'm in here, I'm listening.
All right, I see on the chat, Huitimulo says, it looked like I am running far behind. Haven't done anything from the first activity. I feel I am now lost. Huiti Mulimo, please raise your hand. So, in fact, let me enable your microphone. Your microphone has been enabled, so you can talk to us and let us know how far are you lost, so that we can see what we can do and assist you. All right. Yes.
No, I haven't done the first. I haven't done the first activity.
Which activity are we talking about, Huti?
No, I've been trying to open from the unit 1. So it says forbidden.
Okay. Perhaps try to log in and out again. And then let's see what's going to happen.
I'm not sure why you are left behind. Please understand that.
No, from the presentation, I believe each and every unit has got an activity to be done.
Yes.
That's what I have done.
Okay, but not for this session. It's just about, we're just sharing the resources that are available. Are you on M1?
Yes.
Okay.
Yes, I'm on M1.
Okay. All right. That's fine. You just keep going. Just keep going. All right. Right. I see Casper is also adding a whole lot of resources. Thank you, Casper. All right. What I have added there is I've added a question. We just like to know what resources you are using, and there's a link there. If you can just complete that, that would help us a lot.
Okay. All right. Thank you. I'll do that.
All right. Who's speaking now, though?
It was Huti Mulim. Yes.
Oh, you want me to get into to go to the website now?
No. If you're doing M1, then just keep going through the units. That's fine. You're not lost. It's just a way of working through all the content. Okay.
All right. No, it's fine. I'll do that. And if ever I've got a problem, I'll come back.
Yes, absolutely.
Yeah, let me also put my email address so that you can use the email address, Ausi.
Okay.
Yeah, the email address is on the chat. So when you're struggling, don't hesitate.
Okay, thank you.
Thank you.
Thank you. All right, any other questions or sharing?
So
Anybody?
Muremi on the chat says, good day. I would like to specialize on coding and robotics on my topic. Do you think I'll get enough sources?
For what?
I'm going to unmute Muremi. Muremi, your microphone has been enabled. Let's go. Muremi, over to you. Your microphone has been enabled. All right. While Muremi is sharing the microphone, oh, Muremi says for masters.
Woo!
Hmm.
Woo!
And then,
right.
yes. And then I also see a chat from Sarah saying that, wait. So, do you think I'll get enough sources for the masters? So the answer is yes.
You need a supervisor.
Muremi, please unmute yourself. I've enabled your microphone. How? All right. And then Sarah says, please, you can say how can submit the assessment and get it. Oh, yes, you still have time to submit your assessments, Sarah. They are opened up until December. Sarah, you are muted, so you need to click unmute on your microphone. I mean, Muremi, I've enabled your microphone. Yes.
No?
Your microphone has been enabled, Muremi. Let's try again.
Mm-hmm.
Press again, Muremi. Press your microphone.
Right, toch. Oh dear.
All right, then. But as long as you are able to use the chat,
That's fine.
that's fine. And then if we do have any other questions from the participants, feel free to raise your hand and then we shall take it from there.
Awesome. Hello, the person who wanted to do a master's degree, can they just send me an email, please?
Muremi, you want to do your master's degree and you want more of robotics educational resources. Dr. Hose is requesting that you email her. I'm going to throw in my email address again. And then on the subject line, you just say masters.
Yeah, alsjeblieft.
All right.
All right. All right, I think we're finished then. If there are no further questions, we'd love to hear from you. If you can complete the research questionnaire, we'd really appreciate it. And we will also be sending out, Tumelo, can you just put your link in for the Friday 3 o'clock session? If there are any more questions about
Thank
you. Thank you.
Excellent.
So if you have any more questions about the MOOCs and getting it finished. Okay. That'll be really awesome. Okay. Otherwise, we're good. Okay. Thank you, Tumelo, for hosting with me. Thank you to Anzani for sending out the links. And it's been good. Hopefully you've gained some awareness of the resources that are available. If you have any further questions, you're welcome to join Tumelo and I at 3 o'clock on a Friday. And if you could please complete the questionnaire, it'll give us a better idea of what you're actually using in your classrooms and where we need to add and make more resources available. Okay. Thank you, everybody. Have a wonderful afternoon. Let's see somebody coming in now. Ay, tochi. All right. But it's been a wonderful session. Thank you, everybody that joined. Thank you, everybody who contributed. And then we'll see you again next week. Then we're doing M2, and we're starting with sensors on Tuesday and Wednesday. We're doing sensors. All right. Thank you.
Thank you.
Thank you. Are you going to stop our recording for us?
Yep.